Let's kick off the learning series where I will discuss the previous year question of UPSC CSE Mains paper of Electrical Engineering optional, and I'll leave you with the points where you can be extra careful while dealing with the questions in a more interesting and easy way as we go along. This particular question of transmission line was asked in 2017. We will try to solve the second part. Determine the electrical length of a 20-meter long transmission line operating at 1 megahertz. If V is given as V is equal to 0.7 C on the line, take C is equal to 3 into 10 to the power 8 meter per second. So primarily we will deal with the second part of the question. What are the things given here? Electrical length is given as 20 meters. It is operating at frequency is given as 1 megahertz. If V is equal to 0.7 C on the line, basically mu is also given, right? C is also given for consideration 3 into 10 to the power 8 meter per second. What is the ask of the question? We need to find electrical length. This we need to calculate. What is electrical length? That is nothing but beta d. So we need to calculate beta d, right? Now see, d is given, that is nothing. We have d, right? We have information of d, right, which is given as 20 meter. We need to calculate beta, right? We know that beta frequency is given and mu is given. So we know one relation where we can find lambda, and we know that beta in form of lambda, which is 2 pi by lambda, right? Now we need to calculate this lambda, right? We also know that lambda is equal to C upon F, right? We know this. For this given question, lambda will be mu by F. We know that. Try to calculate mu. Mu is 0.7 into C, that is 3.808. This will be 2.1 into 10 to the power 8 meter per second. We will try to substitute this value here. We know the frequency, so lambda can be written as lambda can be written 2.1 into 10 to the power 8 upon F, that is 1 into 10 to the power 6, right? This is meter in second. Okay, so this is gone. This will be 10 to the power 2. This will be lambda is equal to 2 to the power 2, that is 210 meter, right? 210 meter. Now we will substitute this value here, right? Now electrical length beta d is equal to 2 pi by lambda into d. We have lambda, just we have calculated, which is 2 pi upon 210. D is given in our question. What was the D given as? 20 meters, right? 4 pi by 21. This will be, after calculation, this will be 0.5983 radians. This is the answer that we were looking for. The insight is we can use the direct formula relation between beta and phase velocity. That can also be helpful. This question of transmission line was asked in 2017. Show that for a distortionless transmission line, the attenuation constant alpha does not depend on frequency, whereas the phase constant beta depends linearly on it. We have solved a similar question in the part 2 of this playlist, transmission line playlist. You can check it out. What is the ask of the question? The ask of the question that for a distortionless transmission line, right? Attenuation constant, that is alpha, does not depends on frequency. And the second thing is beta, which is called as phase constant. Alpha is attenuation constant, beta is which is called as phase constant. Phase constant beta depends linearly on frequency. So this is the linear form of the equation. We know that now we know the propagation constant gamma, right? Through that we will find alpha and beta, and we will make sure under the distortionless transmission line condition that we are aware of, under distortionless transmission line condition, we will try to extract alpha and beta, and we will make sure that alpha should not be dependent on frequency and beta should be linearly dependent on frequency, right? Now we know we know that propagation constant, which is gamma, is equal to alpha plus j beta. We also know that there is another formula which is r plus j omega l and g omega c, right? What we'll do, we'll try to extract r and g from these. If you'll take r outside, 1 plus j omega l by r, and if you'll take g out, we have taken here only 1 plus j omega c by g, right? Now we don't know the condition, right, of distortionless transmission line. What is the condition? The condition is r by l is equal to g by c. From this we can, or we can also write like this, that l by r is equal to c by g, to make it appropriate, so that we can substitute this value with this. So hence we have made this modification. All right. Okay. Now we will try to substitute this in this equation, right? This will be rg. This will be 1 plus j omega l by r, right? Now 1 plus j omega. C by g can be written as L by R. So we have written L by R. Now if you see here, this is nothing but square of it. Okay, so this can be written as Rg 1 plus j omega L by R whole square. After solving this will be Rg 1 plus j omega L by R. Rg. So this goes inside the bracket, and this becomes under root of Rg into under root of R. This can be written as under root of R under root of G. J can be written as here omega. I'm just simplifying it. This is gone, this becomes this. So Rg plus j omega L. This can be written as G by R. Here we can see which is nothing but alpha plus j beta. If we compare, alpha becomes, if we compare LHS to RHS, right? Alpha becomes under root of Rg and beta becomes j omega L by G by R. Only beta and j omega will be there. Now we can see that here alpha is not dependent on frequency and beta is linearly proportional to omega, right? Linear with frequency. Hence proved. For this particular question, we need to know the distortionless transmission line and its condition. Hey, great. Thank you so much for watching. Please subscribe to the channel Sinc UPSC for such videos. There are plenty of videos coming up for other subjects too. Happy learning.